A very good morning to all of you. Uh, Myself is Dr. Animita Nan Ghosh. Thank you all for being with us. Today is the first day of MycoAsia Journal Web Series 2023. Today our speaker is Dr. Shailendra Kumar. To introduce Dr. Shailendra Kumar, I am requesting to Miss Romana. Miss Romana, now it's over to you.
Okay. Good morning, everyone, and I welcome everyone to this online training program. I feel honored to say that today's online training program is a unique, as we have such a great personality with us, Dr. Shailendra Kumar, sir. Today's guest is a well known professor and a researcher in the field of microbiology with 21 years of teaching experience and 25 years of research experience. He has published more than 30 articles in national and international reputed journals and has authored 11 book chapters. Dr. Shailendra Kumar sir has also delivered several guest lectures, invited talks, and has also participated in more than 25 national, international seminars, conferences, and workshops. He has also organized several conferences, workshops, training programs, and has received several grants from UGC, SERB, and Government of Uttar Pradesh. He is a member of several professional bodies such as Microbiologist Society of India, Society of Biochemists of India, Society for Agriculture Innovation and Development, and Development and Society for Environmental Sustainability. He is also a member of editorial board and reviewer to various journals. Besides this, the guest of today has guided several MSc and PhD students. Sir is honored with Distinguished Scientific Award, Young Scientist Award, Excellence Teaching Award, INSA Visiting Scientist Program Fellowship, and many more. With this brief introduction, I request the esteemed speaker to enlighten us on the topic biostatistics for the beginners. Now,
Uh,
I would like to invite the speaker for his talk. Please, sir.
Thank you, Dr. Romana, for introducing me. Thank you very much for the introduction, and you have introduced me very well. Means I don't expect that high introduction for me,
Thank
and
you for this.
I'll just introduce myself once again. I'm just a student of microbiology, and I know the pain which is felt by the biology students while they are going for the statistical analysis. So, really, it is very tough for us to do the calculations after leaving the mathematics so long. So really, we are always puzzled how to perform the statistical analysis of the data which we have. Basics of biostatistics. So mostly when we start the class of the biostatistics, we see the faces like this. And the student is really puzzled that after so many years again we have to do this. We have to study the calculations. But really, as we go through the research, we find that every data requires to be validated by using some statistical analysis. So it is really very important to do the calculations related to the biostatistics. And this is also important to understand that a biostatistician play a unique role in safeguarding the public health and improving lives through quantitative research. So the data is available, too much of the data is available, but whether that data is significant or not, whether that is useful or not, or it is providing us the information in the right way, that all is dependent upon the biostatistical analysis. If the biostatistical analysis tells us that yes, it is useful and we can go through, then we proceed. Otherwise, we need to drop. But it is also very important to know that where and how to use it, because if you just look at this statement, It's the lighter side of the statistics that there was a statistician who had to cross the river while he did not know how to swim. So he thought of that, okay, no problem. If I don't know to swim, but still I know the statistics, and the statistics tells that there is the depth of the river is only 3 feet. So he tried to cross the river, and you can think of what might have happened. So it is not always the statistics which will help us to say perform the job. So along with the statistics, we need to know what the deviations may be there, and there are much. Like you see here, the variety of the plants, the different plants have the different leaf structure, and we may have a question: what is the length of the leaves in the plants? So definitely we see the different plants have the different leaf length, and we cannot say that what is the exact length of the leaf. But yes, if you do the statistical analysis, then you can tell at least the average length of the leaf of these many plants. So that is the way how the statistics is going to help us. So once you get the average length of the leaf, then you need to know that how much the average is deviating from the uh, sample, that we call the deviation, and how much is it deviating from the mean value, that we say is the mean deviation, and how much is the standard deviation in overall population, that we say standard deviation. Another part of the statistics is the to assume. We assume something, that we say what is the probability. Probability means is a kind of assumption. As we if we toss a coin, then we have two probabilities, either of the heads or tails, if the coin is fair. So simply to say that what is the probability of getting something, that will again be dependent upon the number of the events, as well the number of ways the event can happen. So we will go through this also, and to find out the significance of the data, we will perform the test, t-test and chi-square test. So let us begin with the measure of the central tendencies. The measure of the central tendencies is to find out the mean, median, and mode. These are the three values which lie into the center of the data. So to calculate these mean, median, mode, I think all of you must be having some sort of notebook and pen ready, because there are lots of to do. There are lots of calculations, and that will be very interesting for you all to go through it. While you are going through the slides, you perform the calculations by your own. That will help us to do this workshop a good success. So mainly there are three measure of central tendencies. There are others also, but we will be discussing only about three. That is to find the mean, median, and mode. So to introduce the mean, what is mean? Mean is exactly the average value. Whenever you have some data, and you are asked to say what is the average, then we use the word mean. Like the data given here is 3, 8, 11, 15, 25, and 30. So if you have notebook, you can do it simultaneously. What is the mean value of this data? So to do this, what we need to follow? We need to follow an equation that is called x bar is equal to sigma x upon n, where x is the variables of the numbers, or the digits, or the data. So we need to make a sum of all this data and divide it by the size of the sample. So size of the sample here is 6, and the sum is 92. The value we get 15.33. That is the mean value of the data given above. So it looks very simple. It is really very simple to do this simple calculations to find out the mean. But in case if the data given is having some frequency, that a digit is repeated several times, so how many times is it repeated, that is called frequency, and the total sum of the frequency is the sample size, which is defined by capital N, and then the formula is modified, and this formula becomes x bar is equal to sigma fx upon n, where sigma fx is the sum of the frequency and the x values. So the values are 586 and 586 and 8, which occurs 3 times, 2 times, 4 times, and 1 times respectively. Then we calculate all this sum by doing this calculation. 3 is the f frequency of number 5. 2 is the frequency of number 8. 4 is the frequency of number 6. And 1 is the frequency of number 8. Or 1 is the frequency of, it should be, that should be 2, not 8 exactly. This number should be 2, not 8. So we do the calculation and we find the mean is 5.7. So this also looks bit easy, but generally the data which we have, that is not exactly the way as it was in the previous two calculations, but something it is presented like this, as this the mass of the students in our university is given in this table, that is 62 kilograms having a frequency of 5, means 5 students have the weight range 60 to 62, and 18 students are there who have the range 63 to 65, 42 are 66 to 68, and then 69 to 71, 27 students are there, and 8 students are there who have this weight range 72 to 74. Fine. So now if we need to calculate the this mean on this data, then what should be the formula? So here we need to first get the class mark. Class mark means we cannot use the range for the calculation of the mean. So we need to find exact the average value of the range. So average value of the range will be like 60 plus 62 divided by 2. So the answer will be 61. So class mark given here is the central value of the range, that is 61, 64, 67, 70, and 73. We have put the frequency here, and next to that is we need to calculate the D is the difference. So this formula we are going to use, that is the mean is equal to A plus sigma FD upon N, where D we can calculate. D is calculated by doing minus from xj minus A. A is the assumed mean. Assumed mean is the mean which we have just assumed, the class in which the mean will occur. We assume this. And how do we assume? We need to find out the class in which the n by second value is to be obtained. So what is the n? N here is a total number of the students, that is 100. Means now we need to calculate 100 upon 2, that will be 50, and we need to add the frequencies. 5 plus 18. 5 plus 18 will be 23. 23 plus 42. 23 plus 42, it will be 65, right? So we are getting the third class, which will have the 65th frequency or 65th student. So we say somewhere the mean will lie into this class, right? So to get this, we have assumed that the mean is lying here in this class, and we assume 67 as the assumed mean. Now we have put the value of A, 67, sigma FD. So D is x minus A. X is this value 61, 64, 67, 70, 73, minus A is assumed mean. So we get the values minus 6, minus 3, 0, 3, and 6. Now, we need to do this calculation FD. F is to be multiplied by D. So we get here minus 30, minus 54, 0, 81, and 84. And the sum of this FD will be 45. Place the values here in the formula. X bar is equal to 67 plus 45 by 100. And the X bar is 67.45. The mean value, mean mass of these students, that is 67.45. But still, you see here, there is a bit of the calculation. We can do this even more short in case if we have the regular intervals in the classes. So as we see here in this table, there is a regular interval 61 plus 3, that will make 64. 64 plus 3 will make it 67, and 67 plus 3 will make 70, and 70 plus 3 will make 73. Means there is a regular class interval between these different classes. So we say C is equal to 3, and we can use now this formula, another formula, that is X bar is equal to A plus sigma FU upon N, and this value is to be multiplied by C, or the class interval. So how to get the U? This U is obtained by doing a division of the D. D, as you have seen in the previous table, this the D divided by C. So D is to be divided by C. C is the class interval. So for this first class, it was D was 6 to be divided by 3. It is minus 2. Then it is minus 1, 0, 2, 2. Now you see, again here some typing error has occurred. This should be 1, not 2. This should be 1. So just a minute, just a minute. Okay. So now you see the sigma FU is 15. And assumed mean we have 67 plus 15 by 100 into 3. And again we get the same value. But here the calculation is bit simpler. So we call this coding method for the calculation of arithmetic mean of the group data. So here is a question for you. If you can take this, then you calculate the monthly wage of employees in a company. So there is a company which has about 65 employees in it, and the different category of the employees, they are paid differently. Their salary is given here, monthly wages are given here, and how many employees are getting which range of the salary, that is also given here. You can calculate the arithmetic mean wage of the employees in a company. So I think we can skip this. Okay, so let us proceed with, otherwise it will be taking too long for us to finish,
Yes, sir.
because
Please proceed.
we have got long targets.
Yes.
I will tell the answer, you note down and just verify it after doing it. It is $79.77. The average wage, or the mean monthly wage of the employees in the company will be 79.77. Okay, next central tendency is the calculation of the median, or finding out the median. What is median? If we have the numbers, okay. So if we arrange the data in an array, ascending or descending order, and find out the value which is lying into the center, that value is called the median value. Like as you see here in this data, 3, 4, 4, 5, 6, 8, 8, 8, 10. So total number of the values which are given here, that is 3, 3, 6, and 3, 9, 9. So the central value which lies in the center, that is 6. We can simply say that the median value of this data is 6. And suppose that if we have got a set of the numbers which is not exactly the way we can divide it like 9 was to find out a central value. at the fifth position. If there are 10 numbers or the 10 digits are given, then how to find the median? Because in that case, there will be two values which are lying into the center. Like in this case, 9 and 11, two values are there which are lying in the center. Then what to say, how to decide? Then we need to take the average of both of these two. That is 9 plus 11 uh, divided by 2. So the answer will be 10. Then in that case, you can say the previous median was given there, while in this time, uh, while we are trying to find out the median of the second data set, the 10 number is not written there, but at least we need to understand that it is included into this range of the data. Likewise, it is not always again on the simple data, but the data may be complex and is available in the group form. The data which we have used for the previous calculation of the mean, the same data can be used for the calculation of the median also. Then in that case, how to do this calculation? Median is calculated by following this formula, that is L1 plus n by 2 minus sigma f1, and divided by f median, and further you have to multiply it with the class interval. So L1 here is the lower class boundary of the median class. As we assumed, the mean, the same way we assume the median also. And the class which will contain the median value, that is called the median class. So lower boundary of the median class is found out here. Then n is the number of items in the data, that is the total size of the population, size of the sample. Sigma f1 is the number of frequencies of all classes lower than the median class. तो मीडियन क्लासेस से पहले का जो है क्लासेस, उनका फ्रीक्वेंसी का सम. एफ मीडियन इज द फ्रीक्वेंसी ऑफ द मीडियन क्लास, एंड द सी इज द साइज ऑफ द मीडियन क्लास इंटरवल. So let us just go through this data. The question which was given here for your calculations to calculate the mean. Now we will be doing the median calculation on the same data. That is the wages of the employees in a company. The range of the wages is given here and the number of the employees is here. Total number of employees n is 65, and the median class, how to find out the median class? Again, as we have said, that these are the values of the central tendencies, these are the calculations for the central tendencies. So we assume that the median or mean will lie in the center of the data. So what will be the center will be the 65 total number of the employees is there, divided by 2, that is 32.5. Means wherever the 32.5th employee will be there, that value we will consider as the median value. So hence the class which contains 32nd.5th employee will be the median class. And lower class calculations, if we do the sum of the class frequencies of the lower class than the median class, then it is 8 plus 10 plus 16, that is 34th. So we are getting 34 employees in the third class, while our aim is to get the median class, that is 32.5. 32.5 will also lie into the third class. Hence we decide that the third class, that is the range of 70 to 79.99, that is the median class. And now we put the values into the formula. So what is the formula here? That is the L1 plus, what is the L1? L1 is the lower class boundary of the median class. So look at this data. The median class is this one. And what will be the lower class boundary? So you can see here it is 70, written 70 here. But if you look at the previous class upper boundary, that is 69.99. Means there is something missing between 69.99 and 70. So we will put the intermediate value of this two classes, the higher range of the previous class and this lower range of the median class. So that will be 69.995. So we decide L1 be the 69.995 plus n by 2, that is 65 by 2, minus 18 is the sum of the lower classes than the median class. Sorry. So that is 8 plus 10. 8 plus 10, that is 18. So this is 18 divided by 16. That is the frequency of the median class into 10. 10 is the class interval here. If you look at the table, you see here there is always a difference of 10 values. Fine. 50 to 60, 60, 60 to 70, 70 to 80, 80, 90, 100 and 110. So the class interval is 10. We do this calculation: 69.995 plus 32.5 minus 18 by 16 into 10. And after calculation, you get the median wage, that is 679.06. Now again, I will have a question for you that you have already gone through this data set, the mass of the students in a university in a class, that is given here, the frequency is given here, and you can calculate the median. Fine. Okay, next measure of the central tendency is the mod. Mod is, we say, the mod of a set of the numbers is that value which occurs with the greatest frequency. It is the most common value which occurs repeatedly in the data set. The mod may not exist, or even if does exist, it may not be unique. It is not necessary that it is always be unique. So there are several examples of this. Like you see here, the example one is having the data set 2, 2, 5, 7, 9, 9, 9, 10, 10, 11, 12, 18. So we see here the maximum frequency is of 9. And simply we can say the data set has one mod, that is 9. You look at the second example, the data set is 3, 5, 8, 10, 12, 15, and 16. So we see here all the numbers are unique and they have not occurred more than once. So we say the data set does not have a mod. And you look at the third example, the data set is 2, 3, 4, 4, 4, 5, 5, 7, 7, 9. So we say 7, 7, 9. You see here two numbers are there, 4 and 7, which are occurring repeatedly. So they have occurred 3 times in the data set, and we say this data set is having two mods. One is 4, another is 7. And we say it bimodal data set, and the example one is unimodal data set. We can calculate the mod on the group data also. Like the table with the frequency is given, we can calculate the mod on that. So to calculate the mod on the group data, we need to follow this formula. That is, the mod is equal to L1 plus delta 1 upon delta 1 plus delta 2. And the result is to be multiplied with the C, that is the class interval. So here L1 is the lower class boundary of the modal class. That is the class which contains the mod. Delta 1 is the excess of the modal frequency over frequency of next lower class. That will be the difference of the frequency of the lower class and the modal class. X delta 2 is the excess of modal frequency over the frequency of next higher class, means the next higher class, difference of the frequencies of the next higher class and the modal class is delta 2, and C is the class interval of the modal class. Here we see it is the class interval or size of the modal class interval only. It does not matter that whether the other classes are same, having the same class interval, or different. So this is the equation, this is the question in which we have the modal wages of 65 calculations employee. You need to calculate the modal wage of the 65 employees in a company. So we know L1. We first we need to find out here. Again, the same class will be the modal class, which has the n by second employee. So that is the lower class boundary L1 is 69.995, as was previously done in the median calculation. Delta 1 is 16 minus 10. 16 is the frequency of the model class, and the lower class is 10. So 16 minus 10 is 6. So we put it here. Delta 1 is 6. Delta 1 is 6. And what will be the delta 2? Delta 2 is 16 and 14. Difference of 16 and 14. Next higher class frequency. So that is 2. 6 divided by 6 plus 2 and multiply the result into the number of size of the class interval of the model class. That is 10. 70 to 80. So this is 10, and we perform the calculation, find the mod, that is 77.495. 77.495, or we can say 77.50. So that is all about the calculations for the central tendencies. So three central tendencies we have gone through. One is the mean, median, and mod. So if you have some question related to it, we can have. Otherwise, we'll proceed with. Okay, let us proceed with. So dispersion or deviation. Dispersion or deviation. The degree to which the numerical data tend to spread about an average value is called the variation or dispersion of the data. So generally we say, as you have seen through, the wages of the employees is given. So there is a range, long range, starting from the $50 to $120. Likewise, the weight range is also there, starting from 60 kilograms to 74 kilograms. Likewise, the data is always having some minimum and maximum value, and we need to calculate the average value. And then further we say how much the average value is deviating from the minimum or maximum. So that we say the dispersion or deviation. And the range is the start point and the end point. That is the range. And the mean deviation, we say when we calculate the deviation from the mean value, that is mean deviation. And when we calculate the standard deviation, that is based upon the size of the population. So that is called the standard deviation. And we'll be just going through these two, mean deviation and the standard deviation, into this workshop. So for the calculation of the mean deviation, we need to have the sum of x minus x bar, where x is the value of the that class and x bar is the mean, divided by n. N is the population size or the sample size, not the population size. Mean deviation, if the data given is with the frequency, then we say sigma f, and then we put the vertical lines x minus x bar and divide it all by capital N, that is the sample size. Why we have used here vertical lines? These vertical lines means the result which we obtain by doing a minus from the x to x bar, that will be absolute value. Hence, we will not be using the sign. We will not be using the sign of the values obtained. So like this question is here, find the mean deviation of the set of numbers 2, 3, 6, 8, 11. 2, 3, 6, 8, 11. And then we have the solution. We need to calculate the x bar or the mean, that is 2, 3, 6, 8, 11 sum, and then divided by 5. We obtain the mean is 6. So we get the x bar value, that is 6, and we have the x values 2, 3, 6, 8, and 11. Now we write them: 2 minus 6 plus 3 minus 6 plus 6 minus 6 plus 8 minus 6 plus 11 minus 6. And then we divide the result by 5. 5 is the n, the size of the sample. So you see here we have got -4, -3, 0, 2, 5. But because we have used the vertical lines here, these lines means we are going to use the absolute value without sign. So we'll place it 4 plus 3 plus 0 plus 2 plus 7. And the result is the mean deviation is 2.8. I hope so it is clear. The similar calculation, mean deviation, we can calculate on this data also. The data set given here is of the masses of the students in a class, that is given. We find the class mark, and next to that is we need to calculate it by using a formula, that is sigma f x minus x bar upon n. So to find this value, x minus x bar, x we have got this 61, x bar we have already calculated, that is 67.45. Now we put it here, x minus 67.45. So value which we are getting, that is 6.45, 3.45, 0.45, 2.55, and 5.55. Because we are using here the absolute values, we have not put the sign here. Fine. The frequencies given here are as it is, and we need to make a multiple of the frequency with the x minus x bar. And you get all these calculations done, and the result is 226.50. That is sigma f x minus x bar. Place it into the formula, 226.50 divided by 100. 100 is the sample size, and the value you get, that is 2.26 kilograms. So this is the mean deviation. Mean deviation means this is the deviation which is happening to be recorded on this data from the mean. Our next calculation is about the standard deviation. So standard deviation is calculated by having this information of the mean, that is given by an equation, that is SS denotes here the standard deviation is equal to under root sigma x minus x bar whole square upon capital N. Capital N is always the sample size here. If the frequency is also added here, the standard deviation will be sigma f x minus x bar whole square upon capital N, sample size. Right. We can have it more simplified, sigma x square upon n minus sigma x upon n whole square. The same way, if the frequency is added here, we will use this formula, sigma f x square upon n minus sigma fx upon n whole square. So one is the square root of the x square, another is the square root of the mean, whole square of mean. So the data given here is the mass of the students, and we need to calculate the standard deviation of the masses. We look at this calculation. Class mark is given here, x minus x bar, we already calculated. So we have put it minus 6.45, minus 3.45, minus 0.45, 2.55, 5.55. because we are going to make a square of this difference. So it will be 41.6025, 11.9025, 0.2025, 6.5025, 30.8025. The frequencies are given here. That is sample size n total. Now we need to make multiple of the frequency with the x minus x bar square. So that we calculate here and obtain 852.750. We use the formula for the calculation of the standard deviation, sigma f x minus x bar whole square upon n. So x minus x bar whole square, that we have got 852.7500. We place it here, divided by sample size, that is 100, and we get under root 8.52750. We remove the under root and get the value, that is 2.92 kilogram. So value of the square root mean of 8.52750, we get 2.92. That is the standard deviation of the masses. You can have a look at the difference between the mean deviation and the standard deviation. So you see here, the mean deviation we obtained, that was 2.26, while this standard deviation is 2.92. Uh, but this calculation goes bit lengthy. Means x minus x bar whole square. We are giving it so many big calculations, and further it is multiplying these long numbers with the frequencies. That is again giving us even more higher values to be calculated. So really it is not that easy, and many a times due to the loads of data we may do the mistakes. So we have short method for the computation of the standard deviation, that is given by this equation. That is, standard deviation is equal to under root sigma d square upon n minus sigma d by n whole square. So we know sigma d by n is again the mean. So is mean and values square upon n. The same with the frequency f. And as we used the u in the calculation of the mean, the same way we can use this d and u both here in the calculation of the standard deviation also. So if we are using u, then we need to use the class interval. So we'll put the class interval to be multiplied with the values we obtained after doing the square root mean of the sigma fu square upon n minus sigma fu upon n whole square. So the question here is again the same. I have kept the data same so that you can understand it easily, that how and what the differences are there. So you look at the mass range is given here, class mark is given here. We get x square because we need to have this x square multiplied by x. Okay. So x square is given here, frequency is given here, and we perform this calculation fx square. Fx square, oh, it's going even lengthier calculations. Fine. Fx square, it is 4,55,803. Now we put this value into this equation, into this formula. That is 4,55,802, 803 divided by 100 minus this. We know the value is the mean. So we know the mean of this data 67.45 and put the whole square. And finally we get under root 8.5275, and the standard deviation we calculate is 2.92 kilograms. But this calculation is very lengthy, very, very lengthy. Now we go for the short computations, that is the use of D. So D we already get. D is equal to x minus A. A is the assumed mean and x is the class uh, values of the classes. Class mark, we say class mark. So we get here D minus 6, minus 3, 0, 3, and 6 for each of the classes. Frequencies are the same. We need to put the FD. FD means the multiplication of the frequency with the D. So we get it here minus 30, minus 54, 81, 48. And we need to place the FD square. Means we need to do the square of D and then multiply by F. So we do this and get the value. So sigma FD is 45, while sigma FD square is 873. Now we put these values into the formula. Sigma FD square. Sigma FD square is 873 divided by 100, that is the sample size, minus sigma FD is 45 upon n, that is 100 whole square. So we get here 8.73 minus 0.45 whole square, that is further under root 8.5275, and the standard deviation is 2.92 kilograms. Another calculation we can perform on the same data, getting the same results, but formula is different here. You know U is equal to D by C. So D in the previous calculations you have already seen minus 6, minus 3. C is the class interval, that is 61 plus 3 plus 3 plus 3 plus 3, means there is always a regular class interval 3. So we can just divide the D by C and get U minus 2, minus 1, 0, 1, 2. Now you see here FU calculation is so simple, minus 10, minus 18, 0, 27, 16. And FD square is also not that lengthy. It is 20, 18, 0, 27, and 32. Sigma FU square is 97. Sigma FU is 15. And now we place these values into this formula and get C. C is 3. 97 by 100 minus 15 by 100 whole square. So 3 under root 0.97 minus 0.15 whole square. 3 into 0.97 minus 0.0225. And we get this value 3 under root 0.39475. Fine. And finally, the value we get, that is 2.92 kilogram. No change. No change in the result, but the method is more simplified and is easy and gives you accurate calculations without doing the mistakes due to the lengthy calculations. So we use this formula for the calculation of the standard deviation in very short steps, least calculation errors. So for the calculation of the probability, again we have some formula. Say, for example, if there is an event which can happen in h ways, so out of a total n possible equally likely ways, the possibility or the probability of occurrence of the event, that is given here by h by n. So look at this, probability of the event is equal to h by n. H is the number of possible ways it can happen, and n is the possible equally likely ways. And the probability of non-occurrence of the event is given here by probability of not E, that is n minus h, that is 1 minus h by n. 1 minus h by n, or that is also written as 1 minus probability of the event E. So if the event is not happening, that means something else will happen. That is the probability of non-occurrence. So this is an example. Let E be the event that the number 3 or 4 turn up in a single toss of die. We know we all have played the Ludo. Ludo has the 6 faces having the numbers engraved into it 1, 2, 3, 4, 5, and 6. So if the Ludo die is tossed, then what is the probability of getting 3 or 4 in a single toss? So there are 6 ways the die can fall. Either it can be 1, 2, 3, or 4. And if the die is fair, we can assume these 6 ways to be likely equally. Since E can occur in 2 ways, we have probability of the event E, that is 3 or 4. So that is 1 by 3. Fine. The probability of not getting 3 or 4, that will be n minus h by n, that is 1 minus h by n, that is 1 minus probability of event E, that is 1 minus 1 by 3, and the probability of not getting 3 or 4 will be 2 by 3. So 1 by 3 is the probability of getting 3 or 4, and not getting 3 or 4, the probability will be 2 by 3. The conditional probabilities, the conditional probability means when some condition is there, like if there is a sequential event, event E1, E2, then we say E2 will happen after the event E1 has happened. That is called the compound event. And for the calculation of the probability of the event E2, E1, E2, we write it here, probability of event E1, E2 is equal to probability of event E1 and probability of event E2 when E1 has already happened. And for the independent events, if both the events are to happen independently, they are not dependent on each other, then the probability of event E1 and E2 will be the probability of event E1 and probability of event E2. Means both the events are independent and they are not dependent on each other. Likewise, for 3 different events, in case of the compound events, the probability of event E1, E2, E3, it will be probability of event E1, probability of event E2 when E1 has happened, and the probability of event E3 when E1 and E2 both have happened. That is called the compound event. And the independent event, if the probability of event E1, E2, E3, that is given by probability of event E1, probability of event E2, probability of event E3. So in case of the independent event, the happening or not happening of any of these events is not affecting the happening of the other event. So all the events are independent and any of them can happen at any time. So there are a few questions for the workshop attendees. They can solve it very quickly. Let E1 and E2 be the events heads on toss, fifth toss, and heads on sixth toss of a coin respectively. You have to calculate the probability of heads on both the fifth and sixth tosses, assuming the coin is fair. So first of all, you have to say whether the event E1 is affecting the event E2. Event E1 is independent and event E2 is independent. Means both the events E1 and E2 are independent. So on the fifth toss, the heads is a independent event, and heads on sixth toss is also an independent event. Means the probability of getting heads on fifth toss is 1 by 2, and the probability of getting heads on sixth toss is also probably that is 1 by 2, and hence the probability of getting heads on fifth and sixth toss, that will be 1 by 2 into 1 by 2, that is 1 by 4. If the probability that A will be alive in 20 years is 0.7, and that the probability that B will be alive in 20 years is so you got the probability for the life of 2 A is 0.7 and B is 0.5. So the probability of both will be alive in 20 years is 0.7 multiplied by 0.5, and that will be 0.35. The probability that both will be alive in 20 years is 0.35. Another question is, suppose a box contains 3 white balls and 2 black balls. Let E1 be the event first ball drawn is black, and E2 be the event that the second ball drawn is black, where the balls drawn are not replaced after being drawn. Calculate the probability of event E1 and E2. So first time when you are drawing, there are total number of balls 5, and out of 5 balls, 3 are white and 2 are black. And what we have assumed here, that the first ball drawn is black. First ball drawn is black. So the probability of getting first ball drawn is black is 2 by 3. And the probability that the second ball drawn is black, that will be the probability 1 by 4, because total number of balls is 4, and getting a black ball is 1, because 1 has already been drawn in the event E1. So the total probability of getting uh, E1 and E2 both, that will be 2 by 5 multiplied by 1 by 4, that is 1 by 10. There are certain events which are called mutually exclusive events. When two or more events are called mutual, if the occurrence of one of them excludes the occurrence of the other. Thus, if E1 and E2 are mutually exclusive events, then the probability of event E1, E2 is 0, because both of the events will not happen ever. So if E1 plus E2 denotes the event that either E1 or E2 or both occur, then we have this formula: probability of event E1 plus E2 is equal to probability of E1 plus probability of E2 minus probability of event E2, E1, E2. Okay. So in case if it is a mutually exclusive event, then this is going to be 0. And the formula, this equation will be further rewritten as probability of event E1 plus E2 is probability of event E1 plus probability of E2. Okay. If event E1 is the event drawing an ace from a deck of cards, and E2 is the event drawing a king. So you know ace and king both are available. How many aces are there in a complete set of cards and how many kings? So we say there are 4 aces and 4 kings. Means an ace cannot belong to a king, or king cannot belong to the ace. Then what is the probability of drawing either an ace or a king in a single draw? So both are independent events and they do not affect each other. The probability of event E1 is 4 by 52, that is 1 by 3, 1 by 13. And the probability of event E2 is 4 by 52, that is also 1 by 13. For the event E1 and E2, the probability given is probability event E1 plus probability of event E2. And we get the probability of both the events, that is 2 by 13. Because these are not mutually exclusive. If the E1 is the event drawing an ace from a deck of cards and E2 is the event drawing a spade, so we all know there are total number of spades 13, And how many aces are there? 4. So what is the probability of drawing an ace or a spade or both in a single draw? What will be probability of event E1 plus E2? Because this is a kind of mutually exclusive event. In the first draw, in a single draw, it is possible to draw the ace of a spade. So we have this calculation to be done using this formula: probability of event E1 plus E2, probability of event E1 plus probability of E2 minus probability of event E1 E2. Probability of event E1 plus E2, that is 4 by 52, is of the E1, because there are 4 aces out of 52 cards. There are 13 spades out of 52 cards, minus probability even E2 means there is only a single ace out of 52 cards which belongs to a spade. So the total probability will be 16 by 52, and that is equivalent to 4 by 13. So probability that an ace or a spade or both will occur, that is 4 by 13. So here is another related question to do: find the probability of boys and girls in a families with 3 children, assuming equal probability for the boys and girls. So let B the event boy in the family and G is the event girl in the family. The probability of boy is equal to probability of girl, because both of them are having the same probability, that is 1 by 2. So the family may have 3 boys, that is represented here by BBB. Then probability of BBB is probability of B, probability B, probability B, that is 1 by 8. 1 by 2 into 1 by 2 into 1 by 2, that is 1 by 8. The same way the family with the 3 girls, that is GGG, then probability of 3 girls is also 1 by 8. Probability of 2 boys and 1 girl, 2 boys and 1 girl. So this may either be BBG or BGB or GBB. Then how to write the probability? This will be probability of BBG plus probability of BGB plus probability of GBB. And we get this, all the probabilities of the different set of these representatives. So it is 1 by 8 plus 1 by 8 plus 1 by 8, that is 3 by 8. 1 boy and 2 girls. Then the probability will be calculated as 3 by 8. Okay. So the probability of 1 boy and 2 girls, that will also be 3 by 8. We can draw this probability distribution table. So if there is a 0 boy, the probability is 1 by 8. That is all 3 girls. Probability of 1 boy, that is 3 by 8. Probability of 2 boys and 1 girl, that is also 3 by 8. And the probability of 3 girls, 3 boys, not girls, that is 1 by 8. So we can draw this discrete probability table by calculating these probabilities. And further, so after doing this probability calculations, we will proceed to the last stop of our workshop, that is the calculations for the t-test. T-test is a student's t-test. That was the test designed by a statistician with an acronym student. Since then, it has been called the student's t-test. And we do this test for the calculation of the level of significance, that whether the data which has been provided, that is significant or not. So that is done by doing the calculation. T is equal to x bar minus mu upon s under root n minus 1, where x bar is the sample mean, the mean which we have been calculating through this workshop, minus mu is the population mean, and this is to be divided by the standard deviation. and then under root n minus 1. N is the sample size which has been used for the calculation of the sample mean, minus 1. And we need to calculate the value of the t, and at a level of significance, whichever is asked by the question, to verify the hypothesis. So hypothesis is to be generated. Either we need to agree with the findings or we need to disagree with the findings. So like you see here in this question, a machine has produced washers having a thickness of 0.50 millimeters, and a sampling is done to determine whether the machine is in proper working order or not. So 10 washers samples were taken for the purpose, and the mean thickness was calculated as 0.53 millimeter, and the standard deviation of the sample, that was 0.03 millimeter. Now you have to do the test for the hypothesis that the machine is in proper working order using a level of significance of 0.05 and 0.01. This 0.05 level of significance means what? 0.01 level of significance means what? Exactly. So we say that we are 95% confident that the machine is in proper working order. 0.05 means we are 95% confident that the machine is in proper working order, and 0.01 means we are 1% confident about the machine's working. Okay, so we hypothesize H0. H0 is the null hypothesis. Null hypothesis is when the population mean is 0.50, okay, and the sample mean is also 0.50, then we say the machine is in proper working order. If the sample mean and the population mean differ, then we say that we need to reject the hypothesis. We need to reject the null hypothesis and say that the machine is not in proper working order. Under the hypothesis, null hypothesis, we have this calculation t is equal to x bar minus mu upon s under root n minus 1. Then we do this calculation. X bar given here is 0.53 mm and mu is 0.50 mm, and S standard deviation is 0.03. Under root 10 minus 1 is 9. Okay. And the result which we get is 3. So to perform a two-tailed test for at the level of significance 0.05, we accept the hypothesis if the t-test values are between the values we get inside the interval of t 0.975 to 0.975. That is for 9 degrees of freedom. This interval, at this interval, minus t2 plus t, at 0.975, we get the value minus 2.26 to 2.26. So if the calculated t value is between these values, minus 2.26 to 2.26, we say that the machine is in proper working order. But because if we see here that the value which we have got, the t-test value is 3, which is beyond this 2.26, means the machine is not working properly. Or we can say that we cannot accept the hypothesis that the machine is in proper working order at 95% confidence. So we are 95% confident that the machine is not working properly. And for two-tail test at 0.01 level of significance, we accept the hypothesis if it lies inside the interval for minus t 0.995 to t 0.995 for 9 degrees of freedom. The interval values is minus 3.25 to 3.25. So we see here that the calculated t value we have got is 3, which lies between this range minus 3.25 to 3.25, and hence we can say that we need to agree with this hypothesis at 0.995 0, 1 level of significance, the machine is properly working. So you see, simply the changing of the level of significance can change the acceptance. So we need first to decide that what level of significance do we need and which value is more appropriate for us, how much liberty we can give for the data to deviate from the standard. So if we decide that, it is easy to finalize that whether this data which we are generating using this machine or the experiment, that is significant or not. If the difference is fine, if there is no significant difference, means it is acceptable. If there is a difference, means there are certain factors which might have affected the value. Okay, another test is the chi-square test. Chi-square test, that is a measure of discrepancy between the observed and expected frequencies, which is calculated by this formula, that is chi-square is equal to O1 minus E1 whole square upon E1 plus O2 minus E2 whole square upon E2 plus E3 minus E3 whole square upon E3 plus so on. So finally we devise this equation. Chi square is equal to sigma Oj minus Ej whole square upon Ej. That is, we need to get the difference between the observed frequency minus expected frequency whole square and divided by expected frequency. So a question is given here. A random number table of 250 digits showed the following distribution of the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Fine. The question is, does the observed distribution differ significantly from the expected distribution? Does the observed distributions differ significantly from the expected distribution? So we have got this table, chi-square calculation we need to do. So the digits are here 0, 1, 2, 3, 4, 5, 6, 7, and 9. Observed frequencies are 17, 31, 29, 18, 14, 20, 35, 30, 20, 36. And the expected frequency, because we assume that all of these numbers or the digits will occur 25 times with the equal probability. So you can calculate the chi-square for the first digit. So that will be 17. O is 17 minus E is 25 whole square upon 25. Likewise, you do it for 31 minus 25 whole square upon 25. 29 minus 25 whole square upon 25. 18 minus 25 whole square upon 25. 14 minus 25 whole square upon 25. Likewise, you need to put all these values and then make a sum of it. And finally, you get the value for the chi-square, that is 23.3. 23.3. And because total 10 digits are there, so to calculate the degrees of freedom, we need to do k minus 1. Variable degrees, number of degrees of freedom, V is equal to k minus 1. K is 9. K is 10 minus 1. So that will be the 9. So with the 9 degrees of freedom, the critical value for the chi-square test at 0.99%, 0.99% level of significance, that is 99% confidence level, it is 21.7, while the calculated value is 23.7, because 23.3, 23.3 which we have got through the calculation is more than 21.7. 21.7 is the tabled value for the chi-square test at 0.01 level of significance, and the Calculated value we have got is 23.3, which is higher than the tabled value, and hence we say that the observed distribution differs significantly from the expected distribution. If the calculated value was less than the tabled value, then we could have said that the observed distribution is not significantly different than the expected distribution. Is it fine? Should we proceed? We'll have one more calculation, and that's it. That is the last calculation we are going to perform in this event.
Yes, sir. You can proceed.
Okay, fine. Okay. So there is a survey of 320 families of 5 children, which reveals the distribution showed in the table given below. And you have to see whether the result is consistent with the hypothesis that male and female birth are equal probable. So you see here, uh, a family with the 5 boys and 0 girls. Number of families is 18. 4 boys and 1 girl is 56. 3 boys and 2 girls is 110. 2 boys and 3 girls 88. 1 boy and 4 girls 40. 0 boys and 5 girls are 8. And total number of families is 320. So first of all, we need to calculate the probability for the male and female birth. The probability of the male birth is defined by P, and the probability of a female birth is defined by Q. Q is equal to 1 minus P. The probability of female birth, then the probability of 5 boys, 4 boys and 1 girl, 3 boys and 2 girls, 2 boys and 3 girls, 1 boy and 4 girls and 5 girls. It can be calculated by following this formula, that is the P plus Q whole square whole 5, that is equal to P power 5 plus 5P4 Q plus 10 P cube Q2 plus 10 PQ Q2 plus 5 PQ4 plus Q power 5. Probability for the 5 boys and 0 girls is 1 by 2, because for boys and girls the equal probability is there. For the 5 boys it is 1 by 2, 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 and finally we get it is 1 by 32. Probability of 4 boys and 1 girl, that is uh, 5 by 32. Probability of 3 boys and 2 girls, that is 10 by 32. Probability of 2 boys and 3 girls, that is also 10 by 32. Probability of 1 boy and 4 girls, that is 5 by 32. And probability of 0 boys and 5 girls, that is 1 by 32. So on the same table, we can have the expected frequencies. So this is the observed frequencies. Number of families is the observed frequencies, and the expected frequencies what it should be. So that should be 10, 50, 100 for the 2 boys and 3 girls, 50 for 1 boy and 4 girls, and 0 boys and 5 girls. It should be 10. And further, you can calculate this chi-square test. After you do the calculation for the chi-square, then you have to do the same way as you did in last calculation. 18 minus 10 whole square upon 10. 56 minus 50 whole square upon 50. 110 minus 100 whole square upon 100. 88 minus 100 whole square upon 100. 40 minus 50 whole square upon 50. 8 minus 10 whole square upon 10. And then finally, after the calculations, you get the answer, that is 12. The value for the chi-square test is 12. And at a level of significance of 0.05, we get the tabled value, that is 11.1. 11.1. And at the level of significance of 0.01, The tabled value given here is 15.1 for 5 degrees of freedom. Why 5 degrees? Because there are 6 possibilities: 5 boys, 4 boys, 3 boys, 2 boys, 1 boy, and 0 boy. So total 6 probabilities are there. 6 minus 1. 6 minus 1 is 5. 5 degrees of freedom. We will look into the table for the chi-square test at the 0.05 and 0.01 level of significance. We get the tabled values for the chi-square test at 0.05 and 0.01 level of significance, that is 11.1 and 15.1. Fine. So at 0.05 level of significance, the value is 11.1, while the calculated value is 12. Calculated value is higher than the tabled value. Hence, we cannot accept this hypothesis that it is equally probable. But at the level of significance of 0.01, we find that the calculated value is less than the tabled value. And hence, we conclude that the results are probably significant and male and female births are not equally probable. So, doing this calculation, we can at least conclude this, that the male and female births are not equally probable at the level of significance of 0.01.
Thank you so much, sir, for your wonderful as well as very informative speech on biostatistics. And this is the time for open discussion. I am requesting the dear participants, if you have any questions or any confusions, you can ask our speaker, please.
Yeah, definitely the queries are welcome. We will solve and resolve. Why did I decide to present in biostatistics, though it is not my subject, direct subject?
Okay.
Yeah, because
But
see,
you have, sir, given many basic ideas on
definitely,
biostatistics.
definitely. But I will answer this question which I have raised myself, because you see, if we go to directly to a statistician, so
Hmm.
statisticians, they will not understand the problem of a biology students. That is the
Yeah,
biggest issue. So it is always easy to convey the solution of the problems in our own language. So
definitely.
yeah, so that is why I feel it. It is easy for us to say convey the message related to the bioinformatics if it is done by a biology student. Because if someone who is not related to the biology will not understand what kind of data is generated in biology and how the analysis is required to be done and how to make the students understand about this, that why they are doing it and what will be the impact of it. So to do this all, you need to look it all from the perspective of a biology student. That was the purpose for me to opt this topic. As well, I do teach this component of the biostatistics in my class. So it was an opportunity for me to present it online, because till date I have used the board and pen only for the purpose of the classes. For the first time, I have prepared this all on the PowerPoint. So any query, if you,
Dear participants, if you have any questions or confusion, you can ask our sir. Please write questions in the text box also.
yeah, they can write the message, or I think they are free to unmute also. They can ask the questions. Yeah, Vrati Naik is asking a question. How do we use these basic biostatistics in metagenomic data derived from environmental sample? And how do we determine which statistical test to use? So, Vrati, I'll have to say here that for the analysis of the metagenomic data, these basic biostatistics will not work, because that is to be done using the computer programming, and that requires some high level statistics, uh, which is which is done computationally. not the basics. So it is all very basic biostats which we have discussed. Otherwise, we can follow the biostatistics programs also, which are available through the various suppliers. One of that is the Graphite Prism is there, R is there, MATLAB is there, and so many statistical softwares are available. And these softwares particularly are helpful in doing the analysis of the large data, because the bioinformatics data or the metagenomic data will be very high, very large in size, and it will not be very easy to do that manually. So we need to use the computational bioinformatic analysis softwares for the purpose of the analysis of the data which is generated using the environmental samples metagenomic analysis.
So can we use SPSS software for a large number of variables, like finding out the correlationship between the variables, sir?
Yeah, SPSS particularly helps you to some extent.
Yes.
Means, but that also you cannot use it for the purpose of the analysis of the data which is generated using the sequencers and the bioinformatic analysis.
Okay.
Yeah, means you have certain data which you collect through the sampling in the environment, that you can do.
Okay. Thank you, sir.
All the basics means we can use these equations also into the Excel. And if you put these equations in the Excel, you can perform the calculations on the small number of small size data.
Yes. Like for example, plant growth parameters of comparing.
Yes. Suppose that you prepare the table of your findings, you can do the calculations by putting these formula into a cell
Okay.
and giving the reference cells.
Okay, sir.
Yeah.
Thank you.
In fact, Excel can also provide you help to some extent.
Hmm.
But as if you see what the calculations we have done on the group data, like the frequency is given in a column and the values are given in a different column.
Yes.
So if we have such kind of data there in the Excel, it will not work.
Okay.
For the Excel, we need the raw data. Raw
Okay.
data means as the number of repetitions you
Yes.
have,
Yeah.
that all you need to show them in the different cells.
Yes, sir. In the form of triplicates, for example, if
Yeah,
we are taking
yes, if you have the data available in the triplicates, means you need to put all the three values
raw
there.
data. Yes, sir.
Yeah. So you cannot make a group and then perform the
Yes,
calculations.
yes, sir. Definitely.
Yeah.
Thank you, sir. Thank you.
So that is also helpful. And Excel is very good basic software which is available with us to perform all these basic statistics, like the mean, median, mode you can do the standard deviation, you can perform the t-test
Hmm.
as well. I think you can do chi-square test also on the Excel.
Okay, sir.
Yeah.
Regarding the ANOVA, sir, we can also perform
ANOVA can also be done on Excel.
Okay, sir.
Yeah, ANOVA can also be done on Excel.
Okay.
And it all is very required for those who are pursuing their PhD,
Yes.
because they will have to generate the data, and the data analysis is very must. Whenever you have to say that the experiment which you have performed is producing the data, and that is significant.
Yes, yes, sir. We have to find out the
Yeah.
significance.
I hope our speaker have answered clearly all the questions and confusions. So we can go to the last part of the webinar, the vote of thanks. So on behalf of our MycoAsia Journal organization team, I am really glad to express my vote of thanks. A special thanks to our today's speaker, Dr. Shailendra Kumar sir, for accepting our invitation and for being here with us today. Your valuable information and on the biostatistics have enlightened us, and I hope in coming future we will get you to enrich our knowledge. And I would like to
Exactly.
thank our exactly sir, and I would like to thank our head, Dr. Bel Shinoy sir, for his immense support and his efforts to make this webinar successful. And lastly, I also would like to thank Dr. Gunjan ma'am, Dr. Manohar, and Dr. Romana, and our whole team for making the day wonderful and memorable. Thanks you once again. Thank you.
Thank you, Ananta.
Thank you,
I'm
Anju.
very thankful to
Thank
Dr.
you.
Bele, who gave this opportunity to discuss it here. And I'm available over the email also. You can have my mail ID and reach to me anytime whenever it is required.
Okay, sir. Thank you so much.
Okay,
Have a
fine.
nice day, sir. Thank you,
Okay.
Ramana.
Thank you
Thank
Okay,
you,
all the
so
Manohar.
best,
much.
everybody. See you.